Hello again. Welcome to more math videos. Oh, your favorite, the math videos. Uh, I just made an adding and subtracting polynomials, 8.1. Now we're going to do multiplying a polynomial by a monomial. Hooray! 8 questions here. Should be quick and painless, I think. I would say this is not much harder than adding and subtracting them. I think it's easier than subtracting them probably because less likely to make a mistake. You just have to know one thing is that you're distributing into some parentheses and the exponent addition rule applies where when you multiply things with exponents, they need to be added. Also, like I see it on this first problem here, things without an exponent written still count as one. I have people who tend to forget that, so I just want to tell you now. All right, anyways, oops, turn to brushes here. So let me show you out with some work on this one. Last video I made, I really didn't show a lot of work because it was honestly middle math a lot. I might be able to get away with that here too. So 2x squared and 10x makes 20. I did 2 times 10. X to the third, because this is x to the second, and this is technically x to the 1. So we add those to make a x to the third. Then we do 2x squared and 4x squared, which makes 8. X to the fourth. Please don't forget to add all of them. Let me undo that. That 4 wasn't very good. To the fourth. Don't forget to add all of the exponents. Usually what happens is when people see the same thing like x squared and x squared, they tend to write x squared again because they were used to the adding and subtracting, which when you add and subtract, you don't change the exponents. But when you multiply and divide, you do got to change the exponents. Although thankfully, we're not going to be doing any dividing of polynomials right now. That would be, whew, that's something. I have to admit I didn't show a lot of work on the last one, so I feel more inclined to show you on a few of these here. So let me do it for this one. Negative 8y to the third. Man, that minus sign was super straight across. Go me. 9y squared, 7y, and 6. Boop, boop, boop. So I get positive 7. Oof. Well, let's just start that over again. I get positive 72 y to the fifth. 8 times 9 is 72. A negative times a negative is a positive, and 3 plus 2 makes 5. Then negative 8 times positive 7 is negative 56 y to the fourth, because I had a 3 and a 1. And then last up is negative 48 y cubed. Notice on this one, when it doesn't have a y, yet the thing I'm distributing is, it gains everything. So there's that one, 72 y to the fifth minus 56 y to the fourth minus 48 y to the third. Sorry, I'm typing and doing things carefully because there's like a button on my mouse and I don't want to hit the back button on accident. No, I don't want to test it right here. I'll test it after the video. I was thinking strongly about hitting the button and seeing what happens. All right, let's do another one here. We got 9. I'll write the work on this one, but then I feel after that I am going to start doing mental math as much as possible because I think it'll get the point across without me writing anything. Because honestly, all I'm doing when I write my work is drawing these little arrows to remind me that 9 times 8 goes to make 72, z to the third, because I had a 2 and a 1. And then on this one, this is 9 times 2. Sorry, my 2 kind of looks like a z also, huh? I get 18z to the fifth. Now notice when we were doing these on the, if you watch the 8.1 video, these are not written in standard form. Standard form would have us writing the highest exponent first. The Alex assignment doesn't seem to mind if you don't write it in standard form. Got a 1 there. So it's okay. It didn't say simplify your answer as much as possible and write it in standard form. It would tell you if it wanted standard form. In that case, I would be writing the highest exponent first. All right, let's go. I'm going to do this one without the work here. So let me delete this so you don't get confused. So negative 2 times 6 is negative 12. I also get x to the 7, 4 plus 3. Next up, we get plus 14x to the 6, because negative times a negative is a positive 14. 4 plus 2 is 6. And then last up, we get negative 6x to the fifth, because 4 and 1. Ooh, this video might go faster than the last one. Another one, 9 times 5 is 45, z to the third. And then 9 times 4 is 36 z to the 6. Simple. Just doing the numbers times the numbers and adding the exponents. Is that all I put on this? I didn't make it any harder than this, did I? Oh no, I put some multivariable stuff at the end here. First thing up is I get positive 10, negative times a negative, y to the 8, positive 40, y to the 7, negative 30, y to the 6. Very careful. Lots of simple multiplication stuff here. But if you make an error on a sign, then it's, wrong's wrong. All right, on these last ones here, we got multiple letters. I don't know if writing it down is going to help, but I'll do it on this first one. The reason why I don't feel like it's going to help too much is because when you have multiple letters, all you're really doing is just combining the like letters and then just appending anything else that wasn't part of the like letters in there. I think you'll see what I mean as I write it here. So there's 3 things being distributed. So first is negative 4 times 2. That's negative 8. I'm distributing r, but there's no r, so I'm just going to rewrite the r that I distributed. I'm distributing s, but there was some existing s. Those add together, just like we've been doing in all the other problems. Then we have negative 4 times 5, which is negative 20. This time the r I'm distributing does have some r to go to, which makes r to the 6. But the s I'm distributing doesn't have an s to go to, so I'll write s to the 3. And then last up, negative 4 times negative 7 is positive 28. And the r's and the s's don't have anything to go to, so we'll just combine them. Now, it may be really tempting to maybe try and combine some like terms, and I'm not saying that's impossible that like terms couldn't exist afterwards, but like terms have the same letters with the exact same exponent. So like, for example, s to the 3 and s to the 3 is very tempting, but it also needs to have the same r, so r to the 6 is not present on both, so I can't combine them. When in doubt, maybe best case scenario to leave them separated, although you always do have to be on the lookout for like terms. Man, I don't know what it is. New keyboard's making me off by 1 unit of typing. Like I'm always typing 1 key over from what I expect that I'm typing. To the 3. Okay, just gotta make sure I did it right. All right, next one. The next one's a little weird because it looks like lots of stuff and lots of stuff. It's really actually just the back one going to the front. Okay, I said in my mind I wasn't going to write it, but you know what? After seeing it, I feel like I'm going to write it. But here's what I'm going to do. As I write it, I'm going to write the thing that was on the back in front of the other thing. Yes, that's fair to do. If you don't like the thing that's being distributed to be on the back end, put it on the front end. Doot, doot. So 2 things are going on there. We got 4 and 8, or negative 4 and 8, negative 32. X to the 10. Oops, I wrote a y here. Sorry, this was supposed to be a z. You didn't see nothing. Look at that. That's the most z looking z I've ever seen. Anyways, x to the 10 at 6 and 4. Z to the 3rd, because 1 and 2. Then I'm going to get positive 20 from negative 4 times negative 5. X to the 6, because there wasn't any x's. And z to the 4th. And that should be good. So let's type her in and make sure it's good. Negative 32 x to the 10 z to the 3rd plus 20 x to the 6 z to the... That is the worst looking 4 I've ever written. I am so sorry. This is a that's totally a 4. Ooh, there we go. All right, let me just make sure that looks good. Looks pretty good. And see, that's what I thought was going to happen. What did I do there? Oh, geez. Let me think to myself. Positive 20, x to the... Oh, x to the... Oh, I said x to the... No, x to the... Oh, I wrote x to the 4th at the end. See, this is what happens when you're not careful, man. So it's x to the 6th, z to the 4th. I accidentally hit x again. I told you the keyboard, I keep typing one thing over. Whoopsies. I had it right. I just typed it wrong because I have no excuse. I typed it wrong. All right, there we go. We're all right now. Hey, look, about the same time as the last one. So let's talk about the problems. Pretty much all of the problems were taking something outside a parenthesis and distributing it in, and it was simply a case of taking the numbers and multiplying them, and taking the exponents of the like variables and adding those together. So we did that for the first 6 problems, and down here on 7 and 8, we had multiple letters to distribute or combine. So we combined the samesies and didn't combine the not samesies, and the number still multiplied. Number 8 was slightly unique in that the number that was distributed was actually on the back, so I rewrote the problem with it on the front. You don't have to rewrite it if you have the foresight to distribute it backwards, that's fine. But I chose to do it the way I did it. Either way works. And that's it. All right, so that was 8.2. I hope you enjoyed 8.2. I sure did. This video helped you. I'm glad it did, and I appreciate that you watch it because you're getting help, and that's what matters at the end of the day. So I will see you on the next video. Okay, bye.